For centuries, moving goods across the ocean was treated as a maritime problem. If freight was too slow or expensive, the solution was always the same: build a sleeker hull, install a more powerful engine, or buy a heavier crane. Yet, despite decades of mechanical improvement, the economics of ocean trade barely moved. A ship could cross the Atlantic in days, then spend far longer tied to a pier, while longshoremen hauled barrels, sacks, and wooden crates into its hold by hand. Naval architects kept optimizing the vessel. Almost nobody was looking at the handoffs. And the handoffs were where the money was being lost. The man who changed that wasn't a sailor, an admiral, or a shipbuilder. He was a trucker from North Carolina named Malcolm McLean. McLean liked to tell the story this way. In 1937, he was sitting in his truck at the port of Jersey City, watching dock workers move cotton bale by bale, when he wondered why the whole trailer couldn't simply be lifted onto the ship. McLean saw something the maritime industry had missed. The bottleneck was never the ship, it was the interface, the moment cargo changed hands between one mode of transportation and another. His first idea was clumsy. He wanted to load entire truck trailers onto ships, wheels, axles, chassis, and all, but the chassis was dead weight at sea. It occupied valuable cargo space and contributed nothing to the voyage. The real breakthrough came through subtraction. Remove everything that mattered only on the highway and keep just the detachable cargo box. Turning that idea into a working system required an extraordinary gamble. By the early 1950s, McLean Trucking was one of America's largest motor carriers, but regulations prevented his trucking company from controlling a shipping line. So McLean sold his stake in the trucking empire he had built, borrowed millions, and purchased an aging shipping company called Pan Atlantic. He bet his fortune on an unproven idea before he had a working terminal or a ship designed for the job. McLean supplied the ambition and capital. Much of the engineering came from Keith Tantlinger. Tantlinger helped transform a metal box into a transportation system. He developed reinforced corner fittings, locking mechanisms that allowed cranes to lift and secure containers quickly, and guides that allowed boxes to stack safely aboard ships. Without those connection points, McLean's containers would have been little more than incompatible metal boxes. On April 26, 1956, a converted World War II tanker called the Ideal X sailed from Newark to Houston. It wasn't even a dedicated container ship. It still carried liquid cargo below deck, with 58 metal containers secured above it. But the economics were staggering. Loading loose cargo by hand cost approximately $5.83 per ton. Loading McLean's containers cost about 16 cents per ton. Turnaround at the dock fell from days to hours, and labor savings were only the visible part of the transformation. Sealed steel boxes dramatically reduced the theft that had plagued open cargo. Goods needed less heavy packaging to survive repeated handling. Damage and insurance costs fell, while shipping schedules became more predictable. The container replaced dozens of uncertain human handoffs with one standardized mechanical movement. But none of this happened without a fight. Dock workers and their unions understood what was coming. Work that once required hundreds of people could now be performed by a crane operator and a much smaller crew in a fraction of the time. Traditional ports faced a different problem. Historic piers in places like Manhattan and central London were narrow and surrounded by dense neighborhoods. They had no room for the enormous storage yards, highways, and railway connections container shipping required, so the geography of trade moved. Old downtown wharves emptied. Massive terminals appeared on the edges of cities in places like Newark, Oakland, and Rotterdam. Warehouses followed the highways inland. The container wasn't merely redesigning ships, it was redesigning cities. There was also a coordination problem. McLean used 35-foot containers. His competitor Matson used 24-foot boxes. Different operators had different cranes, chassis, and locking systems. For containerization to become global, the equipment had to be interchangeable. McLean's company, now called Sealand Service, made Tantlinger's patented corner fitting designs available to the international standardization process without charging royalties. It looked contrary to McLean's interests, but he understood that owning a proprietary system nobody else could use was worth far less than participating in a standard the entire world could adopt. The container needed to become a protocol, not merely a product. The Vietnam War accelerated containerization across the Pacific. By the mid 1960s, ports in Vietnam were overwhelmed. Conventional cargo ships waited to unload thousands of separate crates, vehicles, and pieces of military equipment. In 1967, Sealand secured a major Pentagon contract to transport supplies in containers, helping bring order to the congestion. But after unloading in Asia, McLean's ships risked returning across the Pacific empty. An empty ship still consumed fuel and required a crew, but generated no revenue. So Sealand began stopping in Japan to fill those containers with electronics, textiles, auto parts, and other manufactured goods headed for American consumers. Military shipments helped establish regular container service across the Pacific. Japanese exports then provided profitable cargo for the return journey. This accelerated the development of the modern Trans-Pacific Trade Corridor, connecting Asian manufacturing more directly with Western consumers. As transportation costs fell, distance mattered less. Factories could be located thousands of miles from customers. Components could cross multiple borders during production. Businesses could source goods from almost anywhere. The container didn't just make existing trade cheaper, it made entirely new patterns of trade economically possible. But McLean's story doesn't end in uninterrupted triumph. The same focus on operating costs that made him revolutionary eventually contributed to one of his greatest failures. In the late 1970s, when oil prices were extremely high, McLean acquired United States lines and commissioned a fleet of massive vessels called econ ships. The theory was simple. Enormous ships traveling at slow, fuel efficient speeds could undercut competitors on cost per container. It worked as long as fuel remained expensive. Then oil prices fell during the 1980s. Suddenly, the ships were no longer economical marvels, they were simply slow. Faster competitors captured valuable, time sensitive cargo, while United States lines struggled under the debt used to finance its fleet. In 1986, the company filed for bankruptcy. The man who proved that what happened at the dock could matter more than speed at sea was ultimately undone by building an entire system around one assumption that didn't hold. Malcolm McLean didn't invent the metal box. Containers had already been used in mines and on railways for decades. What he invented was a way for the box to travel. He recognized that a truck, crane, ship, and train did not need to be individually revolutionary. They simply needed to agree on how cargo would pass between them. The standardized container gave every part of the network the same dimensions, connection points, and mechanical language. Cargo could now cross an ocean without being unpacked, reorganized, or even touched. That was McLean's real breakthrough. He did not make ships dramatically faster. He shortened their time in port. He did not eliminate distance. He made crossing it cheap and predictable enough for companies to reorganize production around the world. The steel box became one of the 20th century's most important technologies, not because the box itself was remarkable, but because every truck, crane, train, ship, and port could be built around it. McLean's genius was getting all the existing machines to speak the same language.